Welcome to Statics Lectures by Civil Thinking, and today we are going to solve another problem on truss analysis using method of joints. Before I move on, I suggest you to please watch the video lectures on truss analysis one by one in sequence as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's problem. Now in this problem we have to find all the member forces in this given truss using method of joints. Okay, I have already told you when we have to find the member forces in all the members, then we use method of joints, and if we have to find member force in a few or a particular member of a truss, then we use method of sections. Okay, now these are the correct answers. Okay, as we move on, as we solve this problem, we will compare our answers with these, okay, and see if we get them right. Now there are some steps in method of joints. So we have step 1 is draw free body diagram of whole truss. Okay, whole truss, and find the support reactions. Okay, support reactions. This is step 1. This is step 2 is draw free body diagram of each joint one by one and analyze the joint. Okay, now the first step is we have to draw the free body diagram of the whole truss. Okay, now how do we draw the whole free body diagram of the whole truss? We convert the supports into their corresponding support reactions. Now here we have a pin support at A. Okay, and we know in a pin support there are two reactions. Okay, let me draw these two reactions. Okay, because the name of this support is A, so this reaction is AY, because Y is the vertical direction, and I will call this reaction as AX because X is the horizontal direction. I am assuming the coordinate axis like this is X axis and this is Y axis. Okay, now at C we have a roller, and at a roller we only have one reaction. Okay, so this is CY. Okay, now these directions AY and CY are upwards, AX is towards the right. They are only assumed directions. After solving for the support reactions, if we get a positive value of these reactions, that means our assumption was right. Okay, and the direction was actually upwards, and for this one was towards right. But however, if for any of the support reaction we get a negative value, that means the direction of that reaction was wrong and actual direction is opposite to what we assumed now. Okay, so this is the free body diagram. Okay, now we have to find the support reactions using equations of equilibrium. Okay, let me write here equations of equilibrium. Now I have already made a video lecture on equations of equilibrium. If you want to know more about equations of equilibrium, you can watch my video lecture on equations of equilibrium. Okay, but right now I will tell you we have three equations of equilibrium. Summation of moment at any point is 0. Summation of force in the y direction is 0, and summation of force in the x direction is 0. Okay, for a 2D, because this is a 2D truss, we have three equations of equilibrium. Okay, and when we talk about a point, a single point, then we only have these two. Okay, there is no this equation, moment equation, in a point. Okay, now this is a 2D body, we have three equations of equilibrium. Okay, so now let's apply them one by one. Let's apply first one, summation of moment. Let us say I will find the moment at C is 0. I'm assuming the clockwise movements are positive and the anti-clockwise movements are negative. Okay, now AY is causing a clockwise movement, so the moment due to AY is going to be positive. AY multiplied by normal distance between AY and C is 3 plus 1 is 4 meter. Okay, we found the moment due to AY. Now AX, the line of action of AX is passing through C, so the moment of AX at C is 0, so we will not consider AX. Okay, now 5 kilonewton, it is going to cause a clockwise movement at C, so it is going to be positive, so I will write a plus sign here, plus 5 kilonewton multiplied by what is the normal distance between 5 kilonewton and C. Okay, so the normal distance between 5 kilonewton is this, 5 kilonewton and C is this, right? This is the normal distance between point D and point C, right? So how much is the normal distance? It is 4 meters. 4 meters. So we found the moment due to this. Now this 8 kilonewton is going to cause an anti-clockwise movement at C. So I will write a negative sign here. 8 kilonewton multiplied by what is the normal distance between 8 kilonewton and point C? It is 1 meter, as you can see. So this is 1 meter. Okay, we also found the moment due to 8 kilonewton. Now Cy is passing through C, so the moment due to this is going to be 0, so we will not write this. Okay, so we write the moment due to all the forces present on our truss about point C. Okay, so we have to equate all of it to 0, right? So all of it is 0. Okay, now when we rearrange this equation, okay, now 5 kilonewton multiplied by 4 meter, how much is it? Now 5 multiplied by 4 is 20. Okay, and the unit is going to be kilonewton meter, right? So this is 20 kilonewton meter. Okay, and 8 multiplied by 1 is 8, and this is kilonewton meter. Okay, so this is 8 kilonewton meter. Okay, so AY is equal to 8 kilonewton meter minus 20 kilonewton meter divided by 4 meter, right? I have rearranged this equation. Okay, so now 8 minus 20 is what? 8 minus 20 is, now 20 minus 8 is 12, so this is going to be minus 12, right? 8 minus 20 is negative 12 kilonewton meter divided by 4 meter. Okay, now meter and meter will cancel out, so 4 ones and 4 threes 12. Okay, so it is AY is negative 3 kilonewton. Okay, so we got a negative value of the support reaction at A. This AY is negative 3. Okay, so I will write the reaction here because we need this later on. All right, now AY is negative 3 kilonewton. Okay, now since it is negative value, what does it mean? We earlier assumed that AY is upwards, right? We assumed the direction of this support reaction upwards, but we got a negative value right now. It means our assumption is wrong and the actual direction is opposite. Okay, our assumption was upwards, but the actual will be downwards. Okay, the magnitude will be same 3. Okay, so we will erase this negative here. Okay, why? Because negative means negative sign is about direction. Since we corrected the direction, now there is no need to write negative 3 again. Okay, so now we found the AY. Now let us find this CY. Okay, now CY will be only found when we apply this equation, summation of f of y equal to 0, because summation of forces in the y direction equal to 0 will include CY, right? Because CY is a vertical force and summation of f of y means sum of all the forces in y direction or vertical direction. Okay, so let me erase this first, then we will apply this equation. Okay, we applied this equation. Now let us apply summation of f of y equal to 0. Okay, I am assuming upward forces are positive and the downward forces are negative. Okay, now summation f of y is the vertical direction, so we have to add up all the forces in the vertical direction. Okay, now first 3 is downwards, so this is negative 3. right? Because downward forces are negative and upward forces are positive. Negative 3 kilonewton. 8 is also downward, so it is negative 8 kilonewton, right? Cy is upward, so it is positive plus Cy. These are all the forces in the vertical direction. There is no another force, so I will equate it to 0. Okay. Now when we rearrange this, we will get Cy to be 8 kilonewton plus 3 kilonewton. Okay. Now 8 plus 3 is 11, right? So we get the value of Cy to be 11 kilonewton. Okay, this is a positive value. Okay, so this Cy is 11 kilonewton, right? Now since we got a positive value, it means our assumed direction is right. That means the support reaction at C is vertically and upwards. Okay, so I will write it here. Anyways, we don't need to write. Now we have to find this AX reaction, so let me erase this first. Now we will apply summation of forces on the x-axis. Okay, because we applied this, now we have to apply this equation. Okay, I am assuming forces towards right, they are positive, and the forces towards left are negative. Okay, now we have to add up all the forces, all the horizontal forces. Okay, now AX is a horizontal force and it is towards right, so it is positive. And 5 kilonewton is also a horizontal force and it is towards right, so this is also positive, plus 5 kilonewton. And that is all. We don't have more forces in the horizontal, so we will equate it to 0. So from here we will get AX to be negative 5 kilonewton. Okay, so here we go, we found the value of AX to be negative 5 kilonewton. Okay, now negative means our assumed direction is wrong and the actual direction is towards left. Okay, because our assumption was towards right, as you can see. Okay, so we'll erase it. So it is like this, towards left it is 5 kilonewton, right? So we have completed the step 1. We draw the free body diagram of the whole truss and we found the support reactions. Okay, now I will erase all of this and then we will apply step 2. Okay, now what is the step 2? We have to draw the free body diagram of each joint. Okay, and we have to draw the free body diagram of one joint. Okay, that will help us to find all the forces connected to that joint. Okay, for example, when we draw the free body diagram of joint A, now which members are connected to A? It is AB and AD. Okay, so when we analyze joint A, we will get member forces in AB and AD. Okay, similarly when we analyze the joint C, because BC and DC are connected to the joint C. Okay, so we will get these BC and DC or CD when we analyze joint C. Okay, so let's analyze one by one, and we have to begin with a joint which is relatively simple. Okay, now let us begin with joint A. Okay, we have to draw the free body diagram of joint A. Okay, now before that, because a joint is a simple point, right? It is only a point, and for a point we only have two equations of equilibrium. Okay, we have to remove this moment equation. For a joint, for a point, there are only two equations of equilibrium, so we will apply that. Okay, now, and we also assume the member forces as tensile. Okay, we will assume all the forces, all the member forces as tensile, and when we solve and get a numerical value, and if we get a negative value, that means our assumption was wrong and the actual force is compressive. Okay, but we will begin with the assumption that every force in the truss is tensile force. Okay, and the tensile force is shown with an arrow out of the point or away from the joint. Okay, so we have this member AB, so this is force in AB. We will denote the force like this: F subscript AB means force in AB. Then at A we have also connected AD, right? This is force in AD. And in the free body diagram of a joint, remember we have to show all the external forces or the support reactions. Okay, whatever forces we have to show. So we have 3 kilonewton here downwards at A, and we also have 5 kilonewton here, right? And we're assuming this is x-axis, okay, all of this is x-axis. Let me show it here. This is x-axis and this is y-axis, okay. This is x-axis and this is y-axis, okay. So let us apply these two equations to this joint A, okay. Now will we apply this equation first or this equation? Okay, now to save the time, remember the trick, we always apply that equation where a value is known. Okay, for example, at A we have this 3 kilonewton downwards, okay, in the vertical direction or the y direction, okay, but we also have a 5 kilonewton force. 5 kilonewton, it is a known value, right? It is not an unknown, it is a known value in the x direction. Since we have known values in both the directions, we will apply any equation, okay. Otherwise the rule is apply that equation first, in which in that direction where we have some given value, okay. That saves our time. Okay, now right here we can apply an equation. So let's first apply summation of f of y equal to 0, summation of forces in the y equal to 0. Now I'm assuming forces towards the force upward forces are positive and the downward forces are negative, okay. Now FAD is upward, so it is positive, 3 is downward, so it is negative, okay. These are all the forces along the y or the vertical, right? So we have to equate it to 0. So from here we get FAD to be 3 kilonewton, right? So F force in the AD is 3 kilonewton. Since we get a positive value, it means our assumption was right, that is the force is actually tensile force, okay, and we denote the tensile force with T, okay. If it was compressive, we would denote it with C, okay. Now force in AD is 3 kilonewton tension, okay. Now let us compare, let us see our answer here. Force in AD, force in AD is here 3 kilonewton tensile, okay, as you can see here. So our calculations are right, okay. Now let us apply summation of force along the x-axis to be 0. I'm assuming forces towards right, they are positive, okay. Now FAB is towards right, so it is positive. This 5 kilonewton is towards left, okay, so it is negative, okay, minus 3 kilonewton, okay. We have, these are the all forces along the x-axis, so we equate it to 0, okay. Now from this equation, when we rearrange this, we will get force in AB to be 3 kilonewton. This is a positive value, so it is tensile, okay. So let us see the answer in, see the force in AB is, no, this is 5, right? This is 5, not 3. So our calculations are right, okay. Now we have applied the method of joints. We analyzed a joint and we got the values of the forces in the members connected to it, right? That is AB and AD, okay. Now let us analyze C joint, okay, because this seems relatively simple, okay. So let me erase this first. Now at C joint, let us first find this angle because we need this, okay. And when we analyze B joint, we will also need this angle, okay. Let us call this as alpha and this is theta, okay. Now to find the value of theta, we will the perpendicular component of this right angle triangle is given and the base component, okay. So we'll apply the tangent in triangle, right angle triangle, uh, this DAC, right, DAC. Theta is going to be tan inverse of what? Theta is equal to perpendicular, which is 4 divided by base, okay, which is 3 plus 1, right? So it is tan inverse of, normal component is 4 of this triangle, the normal is 4 meter or the perpendicular, whatever you call it, and the base of this triangle is 3 plus 1 meters, okay, because we are analyzing DAC, so it is 4 also, okay. So 4 divided by 4, it is 1, okay, and we know tan inverse of 1 is 45 degrees, okay. So we got the value of theta to be 45 degrees, okay. Now we have to find this alpha, so we will analyze which, DAB, right? So DAB, uh, alpha is going to be tan inverse of, perpendicular is 4 meter, 4, and in DAB The base is 3 meter, right? 3 meters, okay? So let me use the calculator to find the value of alpha here. Tan inverse of 4 divided by 3, okay? This is 53 degrees, okay? It is 53.13, so I will write more accurately 53.13 degrees, okay? So the value of alpha is 53.13 degrees, okay? So we got the value of alpha and theta, so let us erase all of this. Now let us analyze the joint C, okay? Let us say this is joint C, and we have the CD member at C, and we also have CB member, right? So this is force in CD, okay? Remember, I am showing this away arrow, okay, away from the joint or point. It means this is tensile, okay? This is an assumption. This is force in CD, and this is force in BC, okay? And we have this angle theta here, right? And also we have an 11 kilonewton force upwards, okay? So we also have to write this, okay? Now we actually first need to draw the coordinate axis, okay? And I always forget to draw the coordinate axis, so I have to write after, okay, after the free body diagram, okay? So this is our coordinate axis. Now we have this problem here. F force in CD, this FCD arrow, it is neither on the x-axis nor on the y-axis, right? So when I apply these equations, we will not be able to fit FCD, okay? So we have to resolve FCD into its x component and y component, so that we can include the components, okay, along x and y axis in these equations, okay? So let us resolve this force. Now I have already made a video lecture on resolution of forces. If you don't know, please watch the video lecture on that, okay? This is going to be FCD cosine of theta, okay? And this component is going to be FCD sine function of theta, okay? We have resolved it. So let us apply what? F summation of f of y, right? Why not summation of f of x? Because remember, I told you earlier, because on the y-axis there is one value, this is 11. It is given, right? It is a known value, right? It is numerically known. The 11 is known. So we will first apply summation of f of y, right? So let us let me erase this, and we will apply here. So let us first apply summation of forces along y-axis to be 0. I'm assuming upward forces are positive and downward are negative, okay? So this is joint C, right? So 11, it is upwards, 11 kilonewton. Then we have FCD cos sine theta, this is also upwards. FCD sine function of theta, right? Do we have another force along y-axis? No. So we will equate it to 0, okay? So from this equation, I am going to find the value of FCD to be negative 11 kilonewton divided by sine theta. Remember, theta is 45 degrees, okay? So let me use the calculator to find the value. Negative 11 divided by sine 45, okay? Okay, it is equal, FCD is equal to negative 11 square root of 2 kilonewton, okay? Now we got a negative value. It means FCD is equal to what? 11 square root of 2 kilonewton, but this is compressive force, right? Because negative means compressive force, okay? So let us check the answers. Force in CD is 11 square root of 2 kilonewton compressive, okay? So as you can see here, our answer is correct. It means our calculations are right, okay? So let us erase this, and then we will apply this equation, okay? Because we have already applied this, okay? Now let us apply this. Summation of forces along x-axis is 0. I am assuming forces to the right, they are positive. So let us see the x-axis. As you can see, we have FBC, it is towards left, so this is negative. Negative FBC. Then we also have FCD cosine of theta towards right, left, so this is also negative. Do we have another force along x-axis? No. So all of it is equal to 0, right? Now we have already found the value of what? We have already found the value of FCD, right? This is 11 square root of 2, but compressive. So we will use it negative 11 square root of 2 in the calculation, okay? Because we cannot write in calculator C, right? We can use the negative sign, minus sign, right? We cannot use C in the calculator, we can use negative sign. So we will put the value of CD here. It is 11 square root of 2, right? But 11, but this is negative, and negative is going to be positive, right? So 11 square root of 2, it was cosine of what? Cosine of theta, and theta is 45 degrees. Okay, so from here I will get the value of FBC to be what? 11 square root of 2 cos 45 degrees. Okay, so let me use the calculator real fast. So we'll find the value. Okay, 11 square root of 2 multiplied by cos 45. Okay, so I got the value to be 11 kilonewton. Okay, so let us now 11 kilonewton, it is a positive value, so it is tensile force. Okay, now let us see our answers. Force in BC is 11 kilonewton tensile. Okay, so this is correct, it means we are doing right. Okay, so now we have applied analyzed joint C and we got also this. Okay, now we need this BD force. Okay, member in the force in the BD member, right? BD member. Okay, so to find the force in BD, we will analyze joint B, right? Because BD is connected at B. We can also analyze D, but D is, you know, uh, I think more complex, or maybe it is not. I choose joint B. Okay, so let me erase this. Let me draw the coordinate axis first. Let us say this is x axis and this is y axis. Okay, now we are talking about joint B. Okay, now at B we have 8 kilonewton downwards, so I will write this. Let me change the color. This is 8 kilonewton downwards. Okay, now at B we have, this is B joint, right? This is B joint. We have AB, and we have already found the value of AB to be 5 kilonewton tensile. Okay, because it is tensile, so it is away from the joint. Okay, this is 5 kilonewton tensile. And BC, what is the value of BC? As you can see here, force in BC is, did we do any mistake? AB is 5, yes, and BC is 11 kilonewton. It is also tensile, so this is also away from the joint. Okay, this is 11 kilonewton. Okay, now we have this BD member inclined at an angle of alpha here. Okay, this is force in BD, this angle is alpha. Okay, now we will apply first which equation? Now of course we have to resolve this into FBD into x and y component. Okay, because it is neither in x axis nor in y axis. Okay, so we need to resolve it. This is going to be FBD cosine of alpha, and this is going to be FBD times sine function of alpha. Okay, now as you can see here, if we apply summation of force along y-axis equal to 0, assuming upward forces are positive, we can find the value of FBD here. Okay, now see, FBD sine alpha is upward, so it is positive. FBD sine alpha, what is the value of alpha? 53.13, right? 53.13 degree. It is equal, no, not equal. Now then we have 8 kilonewton downwards along the y-axis, so it is negative 8 kilonewton. These are the only forces along y-axis, right? The vertical axis is y-axis, so all of it is 0. So from here I will get the value of FBD to be what? 8 kilonewton divided by sine of 53.13 degree. Okay, so let me use a calculator to find the value. 8 divided by sine of 53.13. Okay, I got the value to be 10. Okay, 10 kilonewton. Since it is a positive value, so it is tensile. Okay, T for tensile. Okay, so let me check the option. As you can see here, FBD, force in the BD, is actually 10 kilonewton, so our calculations are right. Okay, so this is how we solve problems using method of joints. Okay, first we draw the free body diagram of the whole truss and apply equations of equilibrium and find the support reaction, right? Because the first step is always to find the support reactions. Then we analyze one joint one by one, beginning from a simple joint. Okay, and we keep on analyzing another joint until we find all the member forces. Okay, so if you have any doubt, Please comment and give me a thumbs up if you like, and see you in the next class. Thank you.